Warriors. This is our first day, okay? I'm going to make an attempt to flip the classroom now. And hopefully this is going to help you guys with your math. That's the main thing. We're trying to help you with your math. Instead of sitting in class and listening to me lecture or listening to me teach you about certain things and having my bald head shine right in your eyes, now you just get to hear my wonderful voice. And the thing is when we do this every day, you need to have some kind of a spiral notebook or some kind of a composition book where you can collect your notes. I want you to take notes every time you watch one of these. I'm going to try to keep this at no more than 15 minutes. Hopefully most of the time they're going to be around 10 minutes. I want it to be 10 minutes, you know. It should only take 10 minutes for me to explain a lesson to you. Then when you come in tomorrow, that's when you're going to do your homework. That's why we're flipping the classroom. You're not going to do your homework at home. You're going to do your homework in class, which then it would be called classwork, wouldn't it? But anyways, if you have a problem and you're not able to watch the video for homework, don't stress about it. Don't even worry. Don't start calling everybody. Because when you get to school the next day, I'll find time for you to watch the video. When the groups meet, instead of meeting with me, you'll go to the computer and you'll watch the video and you'll take your notes then. But the important thing is you're going to watch the video and you're going to take notes while you watch the video. Now every time we do one of these lessons and you take notes, at the very top of the page, on the top line, you're going to write notes for Monday, March 28th for this one, okay, because this is Monday's video. Now obviously your homework will be done Tuesday in class. So once you watch this video, you don't have to actually do any homework. You just take notes. Tomorrow in class we'll do the practice. So at the top of your page, you're going to write notes for Monday, March 28th, and it's called Unit 7, and it's about circles. Well, let's jump right in now. Now, circles. Circles are, wow, what can we say about circles? Circles are everywhere. Look, I mean, if I look around the classroom right now, and yes, by the way, I am sitting here on a Friday afternoon doing this. That's how I believe in this system, because I want you guys to get better and better and better at math. And if we do it this way and I flip this classroom, then you can watch the videos at home. You can work on some of the problems with me in small groups in class, and then you can work on projects to apply the problems, and I think that's going to help you better. But as I look around the classroom right now, I see circles everywhere. In fact, we have globes in here that are made of circles. We have cans that are actually, these are cylinders, but the bases are made of circles. There's buckets on my desk. There's a bell with a circle around it. But look, all over the earth there are circles. No, I mean, the earth is a circle. Look at that. The earth is a circle. Dartboards are circles. Coins are circles. Tabletops are circles. Wheels are circles. Circles are everywhere, guys. They're everywhere. So when we see something as common as a circle, we start to have questions about it. And we wonder, are there any things that we can find in common between different circles? So let's look at that. Let me make a circle first of all. Okay, here's my circle. Now a circle, basically, if you take right here in the middle, you put a point right in the center. A circle is defined as all of the points that are equal distance from the center. Anywhere I go from the center of this circle to the side shows me that this is a circle, because all of these points will be exactly the same. If they're not the same, if one is longer than the other, then I didn't find the center point, and it's not a circle. It'll be an oval, or it'll be another shape, but it won't be a circle. In order to be a circle, from the center to anywhere on this line right here will have to be the same exact length. Okay? Now, if I go back and I erase those, let's take and put a line right from the center point to the side. That line is going to be called a radius. Okay? A radius. So a radius goes from the center point to any point on the circle. A radius can go from there to there. It can go from here to there. It can go from here to there. It can go anywhere. and every single radius is going to have the same length. If I took a tape measure and I measured them right now, they would all have the same length. Okay? Now, that's one important thing we need to know. A radius is from the center point, from the center to any point on a circle. That's a radius. And the cool thing about doing it this way too, guys, is if you get a little confused, pause the video or rewind the video. Listen to me say it again. I'm going to try to say it as clear as possible. I'm not talking like a Scotsman. What are you doing? Let's do mathematics. I'm not talking. What's the other one that I'm wanting to teach you mathematics? I'm not very confusing. I'm not confusing you. I'm just speaking regular. I'm trying to be normal. I'm trying to make it interesting. At the same time, you picture my face when I'm talking this way. But okay, so you can pause, you can rewind, or you can stay right where you're at. If you're understanding, fine. That's the benefit of this. So far, we have a radius from the center point to any point on a circle makes the radius. But what if we want to go from, we want to find the fattest part of a circle, or how fat a circle is. And I'm not insulting the circle. I'm not calling the circle fat, but you know what I'm saying. The widest part of the circle. The widest part's always going to have to go right through the center, okay? Now, if you go right through the center, you cut the circle in two parts. When you cut the circle in two parts, you find the distance from one side to the other at the thickest part, and that is called the diameter, okay? So we write diameter. So now, if you look at the relationship between a diameter and a radius is from the center point to any point on the circle, but a diameter is from one side of the circle to the other. So actually, a diameter is the radius doubled. So if you want to find the diameter, and let's say they have a circle. Let me draw you a circle here. Where's my circle tool? This is just like it happens in class, isn't it? Here's my circle tool. Okay? And the only thing they're going to show you is a radius. And they even label the radius. They tell you it's 3 meters. Okay? And then they say, what's the diameter of this circle? Well, if the radius is halfway across, the diameter is double that, so that means you times by 2. So if the radius equals 3 meters, you go 3 times 2, the diameter is going to equal 6 meters. Okay? 6 meters for the diameter. So if you find, anytime you find the radius of a circle, you multiply by 2, and you can find the diameter. So you could write something like the diameter equals radius times 2. Okay? And you can actually write down as a note the diameter. I'll just say it, because if I write it, it's going to take longer than 10 minutes. But the diameter is the distance from one side of the circle through the center all the way to the other side. But if it goes through the center, it's going to be at the fattest point. So as long as it starts at one side, goes through the center to the other side, then that's a diameter. A radius is going to start from the center and only go to one point on the circle, and that's going to be a radius. Now, it's been years and years and years they've been studying circles. They've been figuring out different things about circles. Okay, so let me erase this out here. Now, the thing we're going to talk about now is the circumference. Circumference. Oh, let me make sure I spelled this right. Circumference. Circumference. I spelled it right. The circumference is kind of like perimeter. You know how when we learned rectangles and we learned triangles and we learned squares, I always called it the perimeter, the perimeter. The perimeter is the distance around a square or a rectangle. The circumference is the distance around a circle. Now, as they've done studies and studies and studies on circles, they came to find that there is a relationship between the diameter of a circle and the circumference of a circle. Okay? It's always the same. It's something we talked about on Pi Day also. If you take, we talked about pi. That relationship between the diameter of a circle and the distance around a circle is going to be called pi. So we put a little line and we go like this. That's going to be the pi symbol. The pi symbol is actually a number that goes on and on and on. But if you take the radius of a circle, you take the diameter and you times the diameter by pi, and you're going to get the circumference, okay? We're going to call pi 3.14. We're going to always multiply by 3.14. So pi equals 3.14. It really is bigger than that. It's 3.14159, and it keeps going, and it never repeats. It's a really, really long number, but for 5th grade, dude, we can use 3.14. There's actually a formula for finding the circumference. Circumference, I'll put a C, equals pi times diameter. So if you have the diameter, let's say the diameter is, let's say 10 inches, okay? To find the circumference, you're just going to multiply pi times diameter. Now, I just told you pi equals 3.14, so you'd go 3.14 times 10. Now, you guys know the little tricks that I showed you. When you multiply by 10, you just add a 0 onto the end. Okay, so you go 1 times 3.14, you add a 0 onto the end, so it's going to be it's going to be 31.4. You just move the decimal over one place to the right, so you're going to get 31.4. That's going to be the distance around the circle. But you're saying, but Mr. Wandrum, what if they don't give me the diameter of a circle? What if they only give me a radius? Oh, well, I can show you that too. That's easy enough. Okay, here's a radius. Let's say the radius was 4 inches. Remember back here what I told you about? Oh, I erased it. The relationship between a radius and a diameter, you should have it in your notes already. You multiply the radius times 2, and that gives you the diameter. So 4 times 2 is 8. It would be 4 here, 4 there. Together that makes 8. So the diameter is 8 inches. To figure out the circumference, we do pi times diameter. Pi is 3.14, so we go 3.14 times 8. 8 times 4 is 32, carry your 3. 8 times 1 is 8, 9, 10, 11, carry your 1. 8 times 3 is 24, plus 1 is 25. So the circumference of this circle would be 25 and 12/100 inches. Okay? So just to review a little bit, a radius is from the center to any point on the edge of a circle. That's a radius. A diameter cuts the circle in half, goes from one side to the other side, but through the center. This would not be a diameter. It's not going through the center. That's actually called a chord. Okay, we're not working with a chord right now because a chord does not help us find the circumference. Okay, so we know what a radius is, we know what a diameter is, we know that circumference equals pi times diameter, and we know that the diameter, if they give you a radius, you multiply it by 2. Diameter equals radius times 2. And that's it for this lesson. I went a little bit over. You know, I went 13 minutes, but it still was pretty short. If you got to go back and watch anything over and over again, if you want to practice, go measure some things around your house. Measure the diameter of them, and then multiply by 3.14, and that'll give you the circumference.